Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the nature of oxygen. And if the molecular formula containing oxygen atom, then the nature of oxygen atom are required to find out in which functional group the oxygen atom is involved. For example, the oxygen if present in the molecular formula, the nature of oxygen, as we know that it may be hydroxyl group, it may be carbonyl group, aldehyde or ketone, it may be carboxylic group, then it also may present in ester, amide, lactone, lactam, methoxy or methylene dioxy. In a different functional group, oxygen are present in a different way. And how to identify, how to detect the nature of oxygen in a various different functional group we have discussed so far in detail. So today, right now, we are going to discuss about the next point, and which is a very important as far as this topic is concerned. The aspect of this particular topic for determination of structure of an alkaloids that we are discussing, and therefore it is very prominent because those organic compounds containing nitrogen atom are basic in nature, and that's why it is required, it is very necessary to learn the different way, different tests for identifying the nature of oxygen atom. If the alkaloid, as we know that they are the basic in nature, what kind of the molecule shows as a basicity? Those organic compound containing as a nitrogen atom are found to be basic in nature because nitrogen involve lone pair on it. According to as a Lewis base, it has the ability for donation, and therefore a substance which can donate the lone pair is known as a basis, and therefore they serve as a basic property, and therefore the nature of oxygen atom is very prominent to study the nature of nitrogen atom in the alkaloid, because alkaloid containing as a nitrogen atom, number one, all alkaloid are basic in nature. Just now I already told you that. Why they are basic in nature, that the explanation I already altered many times while discussing the alkaloids. All alkaloids are basic in nature and must contain nitrogen, which may be primary, secondary or tertiary, and determined by the general reaction with acetic anhydride, methyl iodide and nitrous acid HNO2. The tertiary amine forms methyl iodide with CH-3 and amine oxide with H2O2. Acetic anhydride, when amines are there, so acetylation reaction takes place, and we will get as immediately the product form is acetyl derivatives form with that acetic anhydride. And methyl iodide is a very important reagent, or what we can call it as, it is very, very special for this reaction for the amine. From that, what kind of the information we will get here? Remember, depending upon the how much mole of the methyl iodide consumed in the reaction, from that we can immediately classify whether it is a primary amine, secondary amine, or tertiary amine. The general formula of amine is RNH2. It is a primary amine, and if you treat this primary amine with the methyl iodide, 2 moles, 3 moles of methyl iodide get consumed to form as a quaternary ammonium salt, because methyl iodide generally immediately react with the primary amine. One of the hydrogen atom get replaced by that methyl group, then second hydrogen atom also get replaced by the methyl iodide. So 2 methyl group already attached to the nitrogen atom. There is no replaceable hydrogen right now, but the lone pair which is present on the nitrogen atom, that also used for the formation of the bonding with the third molecule of that methyl iodide in such a way that they can form as a salt, which is known as quaternary ammonium salt is formed with the 3 moles of methyl iodide. So that is a very good reagent for the classification of primary amine, secondary amine, and the tertiary amine with the help of methyl iodide. So that is a very good reason. And second one also, nitrous acid. Nitrous acid also gives you the idea regarding aliphatic and the aromatic. If you treat the aliphatic amine with primary amine I am talking about, when the primary amine, aliphatic primary amine treated with, or what we can call it as the action with the nitrous acid, gives or produce the alcohol is the final product, or the alcohol is obtained. And when the same reagent, when you are treating with the aromatic primary amine, let's say here is a aniline, the resulting compound formed is a diazonium salt, and in this way we can easily distinguish between aliphatic amines and the primary amine with the help of nitrous acid, HNO2. Nitrous acid in aliphatic amines gives the alcohol, whereas aromatic amines gives the diazonium salt. And as we know that in the third semester we already learned number of products we can achieve, we can derive by treating that diazonium salt. Diazonium salt is a versatile reagent. Variety of the organic compound we can derive from that reagent, that is a diazonium salt. So, and H2O2 also form as oxide over there. Now in the second way, the nature and the number of alkyl groups attached to nitrogen is determined by distillation of an alkaloid with aqueous potassium hydroxide. The formation of methyl aniline, methylamine, dimethylamine, then indicate respectively with the attachment of 1 to 3 methyl group attached to the nitrogen atom. So these are the way of identifying the nature of oxygen atom we have seen in the first case. How, let us see over here. Suppose we have this R, then NH2. This is a, what we can call it as a primary amine. This we can call it as a primary amine. Primary amine, 3 moles of methyl iodide CH3I get consumed, and we are going to get R here you can get the product R N CH3 thrice positive charge I minus, that is a tertiary tetra-ammonium iodide salt is obtained over there, and that clearly indicate that primary amine is present. In the second case, R NH, if it is there, then it requires 2 moles of methyl iodide get consumed across that this is a secondary amine, and you are going to get the product R N, then CH3 R, positive charge on the nitrogen atom, and I minus. That type of the quaternary ammonium, that is the end product in every case, but the number of moles is depending upon the number of moles. We can easily find out, we can easily classify whether it is a primary amine, secondary amine, or the tertiary amine. Let us see over here. See, suppose R, then N, R, that is a tertiary amine, and as we know that it will consume only 1 moles of methyl iodide CH3I, and the resulting compound is from R, then N, here R, and this methyl group. Positive charge comes on that nitrogen atom, and the iodine with the negative. This type of the salt is a quaternary ammonium iodide salt. You can call it as a quaternary ammonium salt, ammonium iodide salt. You can call it as you just call it as a quaternary ammonium salt. Is the end product, and from this we can conclude that, we can infer that what kind of the amine is present in this case, whether it is a primary, secondary, or tertiary. By using this reagent, methyl iodide is a very good reagent for the classification of, for the detection of primary, secondary, and the tertiary amines. Now, how do you classify aromatic and the aliphatic amine from each other? Aromatic and the aliphatic. Do you know aliphatic and the aliphatic and aromatic, right? Aromatic. With the help of the example we are going to see. Aliphatic and the aromatic in the laboratory. While performing qualitative analysis, one test we are performing in the laboratory. What is that? We are taking pinch of substance on wire gauze, putting on a burner. If sooty flame comes, it indicates that the aromatic compound is present. If non-sooty flame, that clearly indicates that the given compound is aliphatic in nature. Chemical method is a very quick method for the identification of aliphatic and the aromatic, but theoretically, how do you, or chemically, another way, aliphatic and the aromatic amines, we are talking about the amines only. Aliphatic amines, let us see here CH3 and NH2. It is a primary amine, right? Now is a primary amine I am talking, and this is aliphatic in nature. Aliphatic. Remember, this is very important as far as this, and the reagent which we are talking about, this HNO2, that is a nitrous acid. This is a nitrous acid we are using, and in the same case we are going to take aromatic compound, as we know that aromatic compound and the aliphatic compound, right? This is aromatic compound, means this amine group, NH2 group, primary amine group attached to a benzene ring, and therefore it becomes as a aromatic amine. This is a aromatic primary amine. This is also as a primary amine. And what I am trying to explain over here, remember, this is a very important test to distinguish. It is a chemical test for the identification or for the detection of aliphatic and the aromatic amine from each other. This is same. What do you expect? What do you expect over here? Do you remember? Can you tell me what will be the product I am going to get over here? This is a HNO2. Then at generally 0 to 5 degrees centigrade, that is a temperature. This is a reaction condition over here, and in that reaction, if you keep the reaction condition by maintaining temperature 0 to 5 degrees centigrade, then and then that reaction takes place, that reaction occurs, means product formed. And what type of the product? Do you remember this? The compound in a third semester we already learned this one, but here you are going to get as a diazonium salt. Remember, this is aromatic compound, and you are going to N2 plus and Cl minus like this. So our only diazonium salt you can call it is over here N2 plus, and generally as a whatever X you can call it as over here X minus. That is this is called as a diazonium salt, and this diazonium salt is a very versatile reagent. Variety of the organic compound or different organic compound we can derive from this. If you treat with water, you will get as a phenol. If you treat with cuprous cyanide, you will get as a cyanobenzene. If you treat with potassium iodide, you will get as a iodobenzene. So number of, if you use with that HBO2, you will get as a benzene. So that are the product, this diazonium salt, the same reagent we have used over there generally. So what do you get over here? Here you are going to get the product. Here remember this, look at this carefully. The same primary amine, but one is a aliphatic and another one is a aromatic primary. This is also as a primary amine. When aromatic compound form as a diazonium salt, this is known as a diazonium salt. Diazonium salt, and whereas in another case directly you will get as a alcohol. This is one of the method for the synthesis of alcohol. Starting from the amine, we can prepare the alcohol. This is one of the method for the synthesis of the alcohol. Remember this way. We are what? You look at here, there is a tremendous change takes place over here. Why I am repeating again and again. You should not forget in your whole life that NH2 group is directly converted into as alcohol. There is a mechanism is there, but remember NH2 group directly converted into as alcohol due to this nitrous acid. So look at the difference here also as a NH2. Most of the students get confused over there. Aliphatic gives you the alcohol, whereas aromatic form as a diazonium salt. That's the main point of discussion, and that you have to remember forever in your lifetime. Now, so next point we are going to discuss over here is a N-methyl group. So here the nature of, because we are discussing the nature of nitrogens, So let's look at the another point over here, that is another group, because nitrogen just now we have seen it may be primary, secondary, tertiary amines, that nitrogen, and that is the C point we are discussing here. Let us see NCH3, that is a N-methyl group, that is the group which we are finding. It is also referred as a N-methyl group. N-methyl group. How will you prove the presence of N-methyl group in alkaloid, or what we can call what ephedrine, that we are going to discuss shortly. Before that, this is the nature what we N-methyl group, and the first time for the detection of N-methyl group, first time inverted or discovered by the one of the famous scientists. The name of that scientist is Herzig-Meyer, and that's why name is given to that method is a Herzig-Meyer method. This one is a Herzig-Meyer method. What is that? Herzig-Meyer method. Herzig-Meyer method. This is a name is given to that method. And what is that method? Let us see what are the reagent or the chemical he used for the detection of that N-methyl group in the alkaloid that we are discussing. This method is employed. This method is employed, or this method is used this method is employed, or this method is used to determine and estimate the number of N-methyl group present in the alkaloid. Remember, this method is employed, or this method is used to determine and estimate the number of N-methyl group present in the alkaloid. The alkaloid is treated with remember, the alkaloid is treated with HI at 300 degrees centigrade. Or they heated the HI at 300 degrees centigrade. Very high temperature, 300 degrees centigrade. When N-methyl groups are converted into methyl iodide, which are passed into alcoholic solution of silver nitrate to form a precipitate of silver iodide. Let's see over here. Same reagent we are going to take over here, NCH3. In the first time, what they have used, that is a concentrated HI heated at 300 degrees centigrade. What they are going to get over here is heated at 300 degrees centigrade, or you can write in this in a simplified way. This N-methyl group further treated with HI, then heated at 300 degrees centigrade. This bond is going to cleave. After cleavage of that bond, what you are going to get? Here you are going to get secondary amine, as well as here you will get methyl iodide. And the number of methyl iodide present in the compound, how do we determine this? Already we learned in our previous lecture, but let us see here. This is a N-methyl group. This is a N-methyl group, right? This is N-methyl group, and this methyl iodide further treated with AgNO3, silver nitrate. Reaction takes place, gives you methyl nitrate, as well as this one is a silver iodide. The precipitate got over there. That precipitate is a dried, weighed, and determined from the weight of AgI. The number of N-methyl group can be found out. That's the reason we already learned in the previous lecture. Okay, and now let us see here nature of heterocyclic. Whatever we have seen all about the nature of the nitrogen atom, we have seen nature of the nitrogen atom, right? And now onward we are going to discuss about the nature of heterocyclic ring. So nature, fifth point we are going to discuss over here, nature of heterocyclic ring. Because how will you prove the presence of heterocyclic ring in the alkaloids? So at that time, how do you explain or how do you give the answer of that question? So this one is I think D, nature of, that is nature of heterocyclic ring. Nature of heterocyclic ring. Heterocyclic ring. Nature of heterocyclic ring. That is the point we are discussing here. Nature of heterocyclic ring. Various methods are used for opening the heterocyclic rings by breaking carbon nitrogen, carbon nitrogen bond and converting it into a saturated hydrocarbon. Hydrocarbon, we know that the organic compound made by carbon and hydrogen is known as hydrocarbon. Saturated and unsaturated, also you are familiar with this word also. Saturated means organic compound containing carbon-carbon single bond. Unsaturated means organic compound containing multiple bonds. And from the nature of hydrocarbon formed, size of the heterocyclic ring can be found out. Following are some important methods for the determination of or for the detection of heterocyclic rings. Let us discuss first method, which is helpful or useful for the detection of nature of heterocyclic ring, which is Hofmann's exhaustive methylation, is known as Hofmann exhaustive methylation. Hofmann's exhaustive Hofmann's exhaustive methylation. Hofmann exhaustive methylation, and in short it is written as HEM. It is written as HEM. Hofmann's exhaustive methylation means HEM, and this method is applicable to heterocyclic rings which contain beta hydrogen atom. Remember, this method is applicable to heterocyclic ring which contain beta hydrogen atom. This method is only applicable when there is a beta hydrogen present. Remember this one. If beta hydrogen atom is not present, we cannot use this method for the detection of nature of heterocyclic compound, and therefore this word is very, very prominent, or what we can call it as a significant for while answering the question based on Hofmann exhaustive methylation. What is that exhaustive methylation? Is that it is used for the detection of heterocyclic ring in the alkaloid, and the condition or necessary and the important condition required for this, there must be beta hydrogen atom is present, then and then this method is applicable, otherwise there is no use of this reaction. It is not useful for the detection. Some other method may be used. So what are that other method that we will see shortly, but here remember this method is applicable to heterocyclic rings which contain beta hydrogen atom. Now remember the point number 1. Listen carefully. The given heterocyclic compound is completely saturated and then treated with excess of methyl iodide to form quaternary ammonium iodide. This is the first point. This is the first step in a Hofmann exhaustive methylation. What is that? The given heterocyclic compound is completely saturated with the suitable reagent, and after getting as a saturated compound, that compound is further treated with excess amount of methyl iodide. After doing this, the resulting compound is formed is a quaternary ammonium iodide. That is the first point. Now the second point, the iodide derivative. The iodide derivative is then converted into its hydroxide derivative by the action of moist Ag2. Whatever quaternary ammonium iodide is obtained, that derivative further treated with moist Ag2O. Moist Ag2O is a word. Moist is a very essential word used over here, are required here. And what the product, what the intermediate is obtained is the quaternary ammonium hydroxide is formed. The hydroxide derivative into its hydroxide derivative by the action of that we already see. The hydroxide derivative on a dry distillation pyrolysis. Dry distillation pyrolysis undergoes Hofmann elimination to open the heterocyclic ring by heating, by breaking CN bond. That is the essential and the very, very important step in this Hofmann exhaustive methylation, because breaking of the CN bond is takes place at this point, and the process is continued till the nitrogen is completely detached from the ring, completely detached or completely separated from the ring. And if a beta hydrogen atom is not available, this method does not work. As I already told you that at the beginning, the essential and the prominent criteria for Hofmann exhaustive methylation, it must have a beta hydrogen atom, then and then this work is done, then and then this process is work. Otherwise, beta hydrogen atom is not present, this method does not work. Remember, note down, this point is very important. The unsaturated compound obtained determine the unsaturated compound obtained. Now, starting with we converted saturated into unsaturated. Now, unsaturated compound obtained determine the nature of the carbon skeleton in the alkaloid. Let us see here one of the example how this method takes place over here. For example, pyridine on Hofmann exhaustive methylation gives 1,3-pentadiene. Example is given here. For example, pyridine, as you know that pyridine is a 6-membered heterocyclic compound. Pyridine on Hofmann exhaustive methylation gives 1,3-pentadiene, gives 1,3-pentadiene. So that is the product we are going to get over here. Now let us see step by step. We are going to go discuss this one. Pyridine, everybody knows that the structure of pyridine, and which is a aromatic base, right? This is the structure of pyridine. Remember, this one is a pyridine, structure of pyridine, this one. And now this pyridine must be treated with sodium metal in presence of ethyl alcohol, and where it produces the nascent hydrogen. In the square bracket I am representing hydrogen atom is nothing but as a nascent hydrogen atom, which is responsible for the reduction of that compound. And what this is unsaturated, aromatic compound are the unsaturated, because they are containing as a carbon-carbon double bond, and therefore it is going to convert into as a saturated like this. And here we are getting what we have removed, all the carbon-carbon double bond is get converted into as a single, and now this compound becomes as a saturated, and this is nothing but as a piperidine. The name of this compound is a piperidine. The name of this compound is piperidine. And after that, this look at now, remember this is the heteroatom, nitrogen atom, and this corner is nothing but as a carbon atom. This is alpha, and next one is called as a beta. This is also as a one and beta. Look at beta position, there are two hydrogen atom. What is the essential condition for the Hofmann exhaustive ethylation? Find out the beta, whether the beta hydrogen atom is present or not. Yes, in this case there is a beta hydrogen atom is present, and therefore it will proceed, or Hofmann exhaustive methylation, this reaction will takes place, and therefore now this compound is a trade. Look at, there are two hydrogen atoms are there, two beta hydrogen atoms, so 2 moles of methyl iodide is essential for this reaction. One will replace this hydrogen atom, and because this let me give here idea what type of the nitrogen atom over here, what type of the amine it is a secondary amine, and as we know that secondary amine will consume 2 methyl iodide and form as a quaternary ammonium iodide over here. Now here you are going to get here N, one methyl group over here, another methyl group you can write here, positive charge comes over there, and I minus, that is a quaternary ammonium iodide. This is a salt formed here over there. This is a quaternary ammonium salt, ammonium iodide. This is a iodide, that is a iodide, which is a quaternary ammonium salt is formed. And when the quaternary ammonium salt is formed, that quaternary ammonium salt or this derivative further treated with moist. Remember, moist Ag2O, right? Ag2O, that is a silver oxide. And what do you get? Here you are going to get another derivative. Remember that iodide, that is ion, here get replaced by hydroxy group. That's it, and you are going to get over here this one here methyl group CH3, then CH3 as it is. I am replacing that iodide group by hydroxy, and this is known as Quaternary. Put the positive. Why I am putting positive charge on the nitrogen atom? Because if you observe this structure carefully, nitrogen normally has 3 bonds, one exceed over there, and therefore positive charge coming on that nitrogen atom. And now look at, here is a hydrogen atom, and now there is it can be after the pyrolysis, what we can call it as a pyrolysis, there is a elimination of water takes place. This is a pyrolysis, and this is a process where the heating process, after heating there is a elimination of water molecule takes place, and what you are going to get? You are going to get here double bond, and the other part of this molecule nitrogen, these 2 methyl groups. This is if you observe this one, so what is that? Still this is a tertiary amine group, and now this tertiary amine group we are using excess amount of the methyl iodide, so use another methyl iodide group over there, and what it will do? Tertiary ammonium. So here you are going to get this N methyl iodide, here methyl, another methyl, and iodide you can write over here, and here is a positive charge. This is again as a quaternary ammonium iodide, and further it is treated with moist Ag2O. What it will do? That iodide get replaced by hydroxyl group, and that's the thing we are here. Double bond here I am putting double bond once again. Then here this is a methyl group, another methyl group, another methyl group, positive charge, and hydroxy group comes on. Now here is a beta hydrogen atom. Look at here. Now this is the nitrogen atom. The reaction reaction continued till the nitrogen atom is completely detached from that ring, and finally again is a pyrolysis. Pyrolysis is a process where it is a heating process, and what you are going to get over there? Here you are going to get this type of the compound, right? This is the compound we are getting. So what type of the compound it is? If you give the numbering 1, 2, 3, 4, 5. Look at 1 and 4 position. 1, 4 pentadiene, right? 1, 4 pentadiene, this one, but it is going to convert into stable form. This is unstable form. So this double bond is shifted from here to here. That is a conjugation takes place over here, and now this is a double bond, and now if you give number 1, 2, 3, 4 and 5, which we got as a 1,3 pentadiene. This is at 1 position double bond, so 1, at 3 position there is a double bond, so 1,3 pent indicate as a 5 carbon atom in the carbon framework, pent and diene, pentadiene. This is a final product, and from this we can easily come to know the nature of the what we can call it nature of the heterocyclic ring. Formation of 1,3 pentadiene indicate that the nitrogen atom must be present in 6-membered heterocyclic ring. Similarly, degradation of pyrrole gives 1,3 butadiene, that we will see in the next lecture. I think with this, let us stop today here. Thank you. Have a nice day.